Alright, so in this video I'm going to go over our notes that we put into our notebooks today. We put them in our notebooks on Tuesday, so you may just want the chance to go over them again, or you may have missed class and you need to go over them now. So the first thing you want to do is glue these notes into your notebook, but then the next thing you want to do is fill them out and go through the problems. So this first problem says, which expressions can be added to find the volume in cubic meters of the solid figure? Select the two answers that apply. Okay, 2 is in bold. We need to make sure we are marking 2 answers. All right, so the reason there's going to be 2 answers to this problem is because there are 2 ways that we can split up this L-shaped figure here. In order to find the volume of this figure, we're going to have to split it into 2 different figures, and you can either split it horizontally or you can split it vertically. And you can see here that I have the first method is splitting it horizontally, and the second method I've split it vertically. It doesn't matter which one you do if you are just simply trying to find the volume of this figure. But in this case, we want to come up with 2 different answers to how you could split up this figure. So that's why we do have to go through both methods in this case. So if you ever come across a problem like this, you need to make sure that you are doing both methods in order to get the correct answer. All right, so let's look at method 1 first. Method 1 splits horizontally, so what we need to do is find the volume of figure A and the volume of figure B. Now I named them A and B in order to keep myself organized here. So first I'm starting with figure A. So A, my length is going this way. So there's no length marked on either one of these 2 corners of the figures. So I'm going to look at the other parts of the figure now. There's nothing marked here. There's nothing marked here, but it is marked down here that it is 4 meters. So if this is 4 meters, that means this is as well, and this, and this, and this. So I can tell that my length is going to be 4 meters. My width is going this way, and I can see that it's marked as 3. And then my height is going up and down this way. Now this entire section is 10 meters, but I only want this section where A begins and ends. So if the entire thing is 10 and I only want this part, I need to know how tall this down here is in B. So in order to find that, I see that it's not marked over here, but over here it's marked as 2. So this is 2 meters, this is 2 meters, and this is 2 meters. So if this part is 2 and the whole thing is 10, that means this section up here must be 8. So my height is 8 meters. Again, this whole side of the figure is 10. This bottom section where B is 2 meters high. So that means the rest of the way up must be 8 meters if the entire thing is 10. Okay? So for figure B, this is the smaller section at the bottom here. Our length is going to be, going back here, it's 4 meters, the same as the length of A. We can see that because the length of B is right here and it's labeled as 4 meters. Our width is going across this way, so that is 8 meters. And then the height of this, as we just discovered, is 2. So it's marked over here as 2, and we know that that is 2 meters. So now we have the dimensions for both of the figures in method 1. So now we can go over to our question here and all of our answers and try and see if we can match up the numbers that we have, that we came up with for our dimensions, and match them with any of the answer choices. So here we have 4, 3, and 8 for one of the figures. So we want them to match here. We don't have 4, 3, and 8. 4, 3, and 8. No. 4. Well, we have 4, 3, and 6, but we're looking for 4, 3, and 8. Here we have 8, 4, and 3. So that those numbers do match. Let's see if the other set of numbers matches what we have for B. 4, 8, and 2. 8, 4, and 2. Those are all the same numbers. So D is the answer for method 1, but now we need to find the numbers that go with method 2. So it's the same figure, so the volume ends up being the same, but the dimensions that we're working with are a little bit different. So this time we split vertically, which means up and down. So let's start with figure A. Our length is going back this way. Now again, we don't have anything marked up here, but if we look at the rest of our figure, we can see that, oh, down here it is marked as 4 meters. So that length is the same up here. Our width going across up here, again, is marked as 3. And our height this time is actually the full 10 because it's not cut off at the bottom. A has the full 10 as its height. Okay, so now we're going to look at B. B is very small over here. Now the length for B, again, is 4 meters because that is our length right here and it's marked as 4. Our width is going across this way and we can see that it's actually marked right there. Our length is, our width is marked here as 4 meters as well. And then the height we know again is 2 meters. Okay, going up and down, we have it marked here as 2 meters. So these are our dimensions for method 2. So now we have to look through our answers here and see if any of these match. So I'm going to look at A. A is 4, 3, and 10. So let me see if we have any matches here. Here I have 10, 3, and 4, so that one works. But let's look and see if the other dimension for option A works with what we have. We have 4, 4, and 2. 4, 2, and 4. Those are the 3 same numbers, so A will work. So our answer for this one is A and D. These are both answers that will solve this, the volume of this figure, okay? All right, so let's look down at the bottom here. Now we are not looking for the dimensions, but we're actually looking for the full volume of this figure. So one way you could do this is to cut it horizontally. So I'm going to start by cutting it horizontally. And then, so now I need to find the length, width, and height in order to find the volume. But I need it of this figure and of this one. So we have to find the length, width, and height of A and B and then add them together. So let's start with A. A is pretty simple. It actually looks exactly like a cube, and we can see that this side is 10 inches, this side is 10 inches, and it's also 10 inches high. So it's going to be 10 by 10 by 10. Oops. This is A. I'm going to label that as A. A is 10 by 10 by 10, and so that volume is actually going to be 1,000. 1,000 inches cubed. Sorry, that cut off a little bit. Okay, and then we're going to go for B. A was very simple. B, the length here, length is going backwards this way, so we know that's 10 inches. The width is this here, 40 inches across. And then the height is up and down, and that would be 10 inches. So 10 times 40 is 400, and then 400 times 10 equals 4,000 inches squared. So that means in order to find the entire volume of this figure, we have to add together these two volumes. And so the total volume of this figure is 5,000 inches squared. So I'm going to put volume, V equals 5,000 inches squared. All right, so I'm going to grab a blank copy of this, and I'm going to split it the other way. All right, so splitting it the other way would be vertically, and if we split it that way, it changes our dimensions a little bit. So this will be A, this will be B. All right, so again, we're working with length times width times height, and A is going to be how long is it? Long is going back this way, length is this dimension here, so that's 10 inches. The width is this this dimension here, and that's another 10 inches. It's not marked here, but if we look back at the parallel edge, or the edge that's right next to it, that is the same size, it's also 10 inches. So we know that that's 10 inches, and the height here is 20 inches. So that's the volume of A, or those are the dimensions of A, but the volume is 10 times 10 being 100. 100 times 20 is 2,000 inches squared. And then we need to find the volume for B. And the length here, again, is 10 inches, same length. Then we have the width. Now the width is this way. We know that this entire thing is 40 inches wide, but we only want the width of B. So how can we figure out what the width of B is? Well, if we look here, it's not labeled, but if we look here or here, we see that the measurement is 10 inches across. So this has to be 10 inches right here. So if this is 10 and the whole thing is 40, that means it's leaving 30 for us here. It's also written right up here on this side. So 30 was there, but if you don't happen to see that, there isn't always a way to figure out how wide something is based on another measurement. So in this case, we did it the hard way, and that's okay. It's good to learn that way. So our width is 30, and the height, which is this measurement right here, is again 10 inches. So if we multiply those together, 10 times 30 is 300, and 300 times 10 is 3,000. So all we have to do is add A and B together, and again, our answer is the same, 5,000 inches squared. Volume equals 5,000 inches squared. Now see, that just goes to show that no matter which way you do it, whether you're cutting it horizontally or you're cutting it vertically, you end up with the same answer. Okay, the dimensions just look a little bit different. So those are the notes for our finding the volume of complex figures. If you have any questions, let me know. You may want to just rewatch this video again because sometimes it takes a few times to really understand it, but you can ask me if you have any questions, all right?